Good morning, student. Today 10th chemistry class. Previous class we have discussed about the acid-base lessons. Now today we will start strong gases and base solution. Strong acid and base solution. You know, previous class we will discuss about indicator, acid react with metal, acid react with carbonate. So many things we are learning about. Today is a very important topic. That is a strong acid and base solutions. You know, previous class we were studying about dilution of acid. Dilution of acids. You know, you take one beaker, you fill it with water. There is a water H2O. Add the sulfuric acid drop by drop or any strong acid. This is the dilution of acid. This is the dilution of acid. Now, if I add the sulfuric acids, slowly add because this is exothermic reaction. Exothermic changes. So, lot of intense heat is produced. So, maybe the heat produced in the beaker is breaking out. So, we add drop by drop sulfuric acid. This process is known as dilution of acid. This process is known as dilution of acid. You know what? If this is a concentrated acid, that is means 100% of hydrogen ion is present. Previous class we learned about this hydrogen ion. That is a hydrogen ion is responsible for acidic nature. This is another name is a proton. This is unstable. When it is dissolved in water, it forms hydronium ion. This is known as hydronium ion. So H plus ion is known as, that is acid, that is hydrogen ion. Another name of hydrogen ion is a proton. This is unstable. When it is dissolved in water, this H plus ion combined with water to form hydronium ion. This topic, previous class we were learning about this. So now the dilution of acids. Dilution of acid. There is a concentrated acid added to the water. Decrease in concentration of H plus ion. H plus ion concentration decreases. This is a very important point. Concentration of H plus ion decreases. When sulfuric acid dissolved in water or any concentrated acid dissolved in water, it is known as dilution of acid. It is known as dilution of acid. When dilution of acids, the H plus ion concentration, that is the power of H plus ion, number of H plus ions decreases in concentration of H plus ion. This is the concentration term. Concentration of H plus ion. This is a hydrogen ion. This is known as hydrogen ion. This phenomena is known as, or this process is known as dilution of acid. This process is known as dilution of acid. So any acid may be strong acid or weak acid. Dilution, decrease in concentration of H plus ion. Decrease in concentration of H plus ion is known as dilution of acids. Next, dilution of base. Same model. Dilution of base. You take one beaker, you fill it with water. This is the water. Beaker containing water. You add sodium hydroxide pellets. Sodium hydroxide pellets. This is a pellets. Pellets. It's like camphor. You see, it's a pellets. Sodium hydroxide pellets. You add, now stir. Using glass jar, you stir. Completely stir. Heat is produced. That is a base dissolved in water. Strong base is dissolved in water. It's a heat is produced. Heat is produced. So this is the exothermic changes. So base dissolved in water, that is known as exothermic changes. So when it is dissolved in water, it produces a OH minus ion. OH minus ion. That is a dilution of base. Dilution of base. Now dilution of base is a decrease in concentration of OH minus ion. Decrease in concentration of OH minus ion. This OH minus ion is a hydroxide ion. Hydroxide ion. So dilution of an acid, decrease in concentration of H plus ion. Dilution of a base is a decrease in concentration of OH minus ion. that is known as dilution. So all the dilution process, concentration decreases. Dilution of acid, decrease in concentration H+ ion. Dilution of base is a decrease in concentration of OH- ion. Now, next topic is a universal indicator. You know, previous class we were learning about indicator, natural indicator, synthetic indicator. That indicator only color changes. It's a qualitative. That is qualitative means whether the given substance acid or base. By using the indicator, the color changes indicating whether the substance acid and base. But here now we are discussing about universal indicator. What is the meaning of universal indicator? Universal indicator means mixture of several indicators. So many indicators is a mixing. So many indicators, many indicators, several indicators mixing to form universal indicator. To form universal indicators. Now, uses of universal indicator quantitatively expressed. Quantitatively expressed hydrogen ion concentration. Hydrogen ion concentration. Quantitative, how much amount of H+ ion is present. That is a universal indicator. Universal indicator. This universal indicator is a mixture of several indicators. Mixture of several indicators. What is the uses? To judge how strong a given acid or base. A given acid, very strong acid or very weak acids, or given base is strong base or weak base. By using universal indicator, easily judges. Easily determine whether the acid is a strong acid or base, is a strong base or weak base. So using universal indicator to judge the strong given acid or base solution. This is very important. Universal indicator is a two form. Universal indicator is a two form. It is available in the market. Universal indicator. One is a paper form. Paper. Universal indicator. Paper form. In our laboratory is the paper form. That is this type of universal indicator. Paper. Light yellow color is the paper form. Universal indicator is a paper form. That's like litmus paper. Like litmus paper. This is a universal indicator paper. Indicator paper form. Universal indicator is a paper form. That is a paper form. Its color is a light yellow. Universal indicator paper is a light yellow color. So universal indicator is a two form available. One is a paper form, another one is a solution form. That is a solution form. This universal indicator solution, universal indicator solution is a combination of several indicators. You know, universal indicator means mixture of several indicators. Mixture of several indicators is known as universal indicator. Universal indicator means mixture of several indicators. Universal indicator two form. One is a paper form, another one is a solution form. Another one is a solution form. In a solution form, there are here four indicators is a mixing. First indicator is a thymol blue. Thymol blue. This is one of the indicator. Thymol blue. Methyl red. Second indicator. Third, bromo-thymol blue. Bromo-thymol blue. Fourth one is a phenolphthalein. So first two indicator, thymol blue. Second, methyl red. Third, bromo-thymol blue. Fourth, phenolphthalein. These four indicator solution equally mixing to form solution form. That is universal indicator. It's a solution form. It is a two form available. One is a paper form, another one is a solution form. Solution form is a mixing of thymol blue, methyl red, bromo-thymol blue, and phenolphthalein. These four indicators is an equal amount mixing to form solution form. That is a universal indicator. This is known as universal indicator. What is the uses of universal indicator? To judge how strong acid or base. How much amount of H+ ion, that is how much strong acid, weak acid, or strong base, or weak base. Easily judges by using the universal indicator. Now, very important point. This is a board point of view. Now you take a one strong acid. You take a one test tube. This is a strong acid. This is a B, C, B. In a test tube A is a strong acid. SA, strong acid. SA means strong acid. Test tube B is a SB, WA, weak acid. Test tube A containing strong acid. Say example sulfuric acid. Test tube B containing weak acid. Say example acetic acid is present. Test tube C, strong base. Test tube B, weak base. You take a 4 test tube. Strong acid, say example sulfuric acid. Strong acid is a sulfuric acid. Weak acid is a acetic acid. CH3COOH is a acetic acid. Strong base, sodium hydroxide. Say example sodium hydroxide. Weak base is a KO. Weak base, ammonium hydroxide. So test tube A containing strong acid, that is a sulfuric acid. Test tube containing is a weak acid, that is known as acetic acid. You know, previous class we learning about acetic acid. Another name is a vinegar. This is a vinegar. Acetic acid another name is a vinegar. Test tube C containing strong base, that is a sodium hydroxide. Strong base is a sodium hydroxide. Test tube D is containing weak base, that is a ammonium hydroxide. This is known as ammonium hydroxide. You take 4 test tubes. Now you take universal indicator solution form. Universal indicator. You add few drops of universal indicator solution. Now it's a strong acid. This strong acid, weak acid, strong base, weak base, all are colorless. All are no color. You add the universal indicator, strong acids, red color formation. That is means strong acid colorless to red color formation. By adding universal indicator to the solution of strong acid, the color of strong acid red color become a red color. So as a strong acid means what's the color? Red color. This is the red color. Second, now you add the universal indicator in a test tube B. That is a containing weak acid. That is the acetic acid. Weak acid is known as acetic acid. You add the acetic acid in a test tube B. Weak acid. The color of this is the colorless weak acid. You add the universal indicator. The color changes from weak acid orange or yellow color formation. Indicating this acid weak acid. This acid is a weak acid. So this orange or yellow color formations is indicating weak acid. Now test tube containing C containing strong base, that is a sodium hydroxide. Sodium hydroxide another name is a caustic soda. Previous class I explained caustic soda formula is NaOH. That is a strong base. That is this test tube C containing strong base, sodium hydroxide. Add the universal indicator. That is a test tube C containing. Add to the test tube C. That is a strong base. This sodium hydroxide is a presence. What happened? That is the strong base. The color violet or indigo is formation. Violet or indigo. Strong base color violet or indigo formation. So colorless to violet color or indigo formation indicating strong base. Universal indicator added to the strong base, the color violet or indigo is known as strong base. Now test tube D containing weak base, that is known as ammonium hydroxide. Very weak base. This is ammonium hydroxide. This is known as ammonium hydroxide. Formula NH4OH. That is the weak base ammonium hydroxide. Weak base is ammonium hydroxide. We add universal indicator to the beaker, that's a test tube containing D weak base. What happened? The color, weak base color plus 2 blue color appear. Blue color formation, that is known as weak base. That is known as weak base. Weak base. You know, you take another test tube that is containing water. This is known as water. The test tube A containing test tube B, test tube E containing water. That is a neutral solution. Now you add a universal indicator to the neutral solution. That is a water molecule. Few drop of universal indicator added to the water. That is a neutral. What is the color formation? That is a green color formation indicating is a neutral. The solution is a indicating. So this universal indicator to judge whether acid strong acid or weak acid or weak base or strong base and neutral. So this universal indicator very important uses whether acid, strong acid or weak acid, base, strong base or weak base. This is the indicating. But previous class we are learning about indicator, that is a synthetic indicator, natural indicator, whether acid or base. But here acid is strong acid or weak acid, base or strong base or weak base, easily identified by using universal indicator. So again I will repeat, what is the meaning of universal indicator? Mixture of several indicators. Mixture of several indicators. What is the use to judge how strong acid or weak base? Okay, universal indicator is a two form. One is a paper form, another one is a solution form. Paper form or solution form. In a solution form, it's a mixture of so many indicators. One is a thymol blue, another one, second one is a methyl red, third one is a bromo-thymol blue, fourth one is a phenolphthalein. These four indicators, equal amount is a mixing to form solution form. Solution form. This indicator is used for whether the acid is given acid, strong acid or weak acid, or given base, strong base or weak base. In a strong acid, the color is a universal indicator. Color, that is a red color formation solution added to the strong acid. Universal indicator added to the weak acid, the color is orange or yellow color formation. Orange or yellow color formation. Universal indicator added to the neutral solution. Say example, water molecule, which color is a green color formations. Now, universal indicator added to the weak base is a color is a blue color. You added to the strong base is a violet or indigo color formation. This is a universal indicator. This is known as universal indicator. Next topic is the pH. The pH scale. pH scale, whether acid or base quantitatively expressed in a hydrogen ion concentration. Quantitatively expressed in hydrogen ion concentration is known as pH. pH of the solutions. Okay? That is the pH. It's a very important topic in 11th standard also. It's a very important topic. pH. pH definition: measuring of hydrogen ion concentration. What? Measuring. Quantitatively measuring, not qualitative. On how much amount? 10% or 5% or 100% of. That is a measuring hydrogen ion concentration. This bracket is indicating concentration. This bracket you see concentration. Now here I will write H plus ion. That is the concentration of hydrogen ion. This bracket indicating concentration of hydrogen ion. That is the measuring of hydrogen ion concentration in solution. Measuring of hydrogen ion concentration solution. Now pH. pH is a potence of hydrogen. This is a German word. Potence of hydrogen ion. Potence of hydrogen ion. This is a German word. This is a German word. German word potence. Potence means power. Power of hydrogen ion. How much power? That is the power of hydrogen ion. That is the pH. pH writing this type. Writing P, then you write here this type of writing. That is the correct way. This is a correct way. Write it up pH symbol. That is, don't write this type. This type is a wrong, or this type. This is a wrong way. This is a correct way writing pH. That is a correct way. That is means what is the meaning? Power of hydrogen ion. Power of hydrogen ion is known as pH. That is a measuring hydrogen ion concentration is known as pH. Measuring hydrogen ion concentration in solution. Not solid or gaseous form, only solution. Measuring H plus ion is known as concentration, pH value. pH value is a potence of hydrogen ion. Potence of hydrogen. Potence means power. Power of hydrogen ion. That is a power. Power of hydrogen ion. This is a German word. Now, pH value is vary from 0 to 14. pH value is varies from 0 to 14. pH value varies from 0 to 14. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is a pH value 0 to 14 is a pH value. So minimum value is 0, pH value, maximum value is 14. As per 10th standard, the minimum value of pH is 0, maximum value of pH is a 14. pH value is a 14. Now you see, pH 0 to 6, that is known as acid. pH value 0 to 6 is known as acid. pH value 0 to 6 is known as acid. Now pH value 8 to 14 is known as base. pH value 8 to 14 is a base, and pH value 7 is a neutral. pH value 7 is a neutral. Say example, neutral is a water. So water pH value is a 7. Water pH value is a 7. That is a neutral. That is why our pH 7 is a water. So we are drinking. If you pH value less than 7, that is maybe 6 or 5, that's acidic water. We are a bit grammar. Don't drink this water. Okay. pH value 0 to 6 is acid, and 7 is a neutral, and 8 to 14 is a base. 8 to 14 is a base. So pH 0 to 6, that is known as acid. pH 7 is a neutral. pH 7 is a neutral. pH 8 to 14 is a base. 8 to 14 is a base. So pH value 0 to 6 is acid, 0 to 6 is acid, pH 7 is a neutral, pH 8 to 14 is a basic solution. These are basic solutions. Now you see very important topic, next continuation. For acidic solution, when solution is acid, acidic solution, pH less than 7. pH is a less than 7 is known as acidic solution. pH less than 7 is acidic solution. Here concentration of H plus ion is greater than concentration of OH minus ion. Greater than OH minus ion. So acidic solution pH is less than 7 is known as acid solution. That is acid solution. In this acid solution, hydrogen ion concentration is greater than hydroxide ion solution. Now next is basic solution. pH is greater than 7. Greater than 7 is known as basic solution. That is a greater than 7. 8 to 14 is a basic solution. In this basic solution, H plus ion concentration is less than OH minus ion concentration. So more OH minus ion in this solution pH value is greater than 7. Now neutral solution. Neutral solution pH value is a 7. pH value is a 7. In this neutral solution pH value is 7. So concentration of H plus ion equal to concentration of OH minus ion. Concentration of H plus ion is equal to concentration of OH minus ion. This is known as neutral solution. That is a pH value is equal to. For acidic solution, pH value is less than 7. That is a 1 to 6. That is a less than 7. Is known as acidic solution. In this pH less than 7. In this solution, acidic solution, concentration of H plus ion is greater than OH minus ion. Concentration of H plus ion is greater than OH minus ion. Now basic solution pH value is greater than 7. 8, 9, 10, 11, 12, 13, 14 is greater than 7. Here concentration of H plus ion is less than OH minus ion concentration. So here OH minus ion maximum concentration for basic solution. For acidic solution, hydrogen ion concentration is a maximum comparing OH minus ion. But neutral solution pH value is a 7. pH value is a 7. Here concentration of H plus ion is equal to concentration of OH minus ion. So number of concentration of H plus ion is equal to number of concentration of OH minus ion. Is known as that solution is known as neutral solution. In this neutral solution pH value is 7. So neutral solution, the example water molecule. The pH formula is there, is not given in a textbook. We are learning about higher secondary, but I will write this formula, pH value formula. It's a very important formula for higher secondary classes. That is the pH formula. pH is equal to negative logarithm of concentration of H plus ion. Concentration of H plus ion. So this is the another formula. That is the pH is equal to 1 by logarithm of H plus ion. You studied higher classes. There is a pH formula. pH is a negative logarithm of H plus ion. Concentration of H, this bracket indicating, square bracket is indicating concentration. So pH is equal to 1 by log H plus ion. Log H plus ion. You see in this formula inversely proportional. That is a pH inversely proportional to the hydrogen ion. So pH value inversely proportional to the hydrogen ion. Hydrogen ion. So you see concentration of H plus ion increasing, so pH value decreasing. pH value decreasing. Now concentration of H plus ion decreasing, pH value increasing from this formula, because pH and the concentration of H plus ion is inversely proportional. So concentration of H plus ion increasing, pH value decreasing. So it become a acidic nature. It become a acidic nature. It become a, that solution is known as acidic nature. Now concentration of H plus ion is decreasing, pH value is increasing. Concentration of H plus ion decreasing, pH value is increasing. That is known as basic solution. This solution will become a basic solution. Okay, tomorrow next class we will see the activity. We will discuss about the pH value. Daily life we will see activity. In our textbook is that one table column is that. We will see the next class. Thank you, students.